Hey guys, this is Black. Welcome back to the YouTube channel. In this video, we will discuss about Java objects. What is Java object? In Java, an object is an instance of a class. It represents a real-world entity and is created from a class blueprint. Objects have attributes and behaviors defined by the class, making them a fundamental concept in object-oriented programming. Java objects encapsulates data and behavior within a single unit. They are created using the new keyword followed by a constructor of a class. Objects can interact with each other by invoking methods or accessing fields. These are the key aspects of Java object. Let's look at these aspects in detail. State and behavior. Objects have state represented by fields or variables and behavior represented by methods. The state defines the property of the object while the behavior defines what the object can do. Class definition. Classes act as blueprints for objects. They define the structure and behavior that object of the class will have. Objects are instances of a class. Instantiation. To use a class and create an object, you instantiate it using the new keyword. This involves calling the class's constructor to initialize the object. Reference variables. Objects are often referred to by reference variables. These variables store the memory address of the actual object. Multiple reference variables can refer to the same object. Inheritance. Java supports inheritance, allowing a class to inherit the properties and methods of another class. This promotes code reuse and the creation of hierarchical relationships between classes. Encapsulation. Encapsulation involves bundling the data and methods that operate on the data within a single unit. Access to the internal details of the object is controlled by access modifiers. Polymorphism. Polymorphism allows objects to be treated as instances of their superclasses, enabling flexibility in code design. It includes method overloading and method overriding. Garbage collection. Java automatically manages memory using garbage collector. It deallocates memory occupied by the objects that are no longer reachable, simplifying memory management for developers. These are the additional aspects of Java object. Let's look at these aspects in detail. Method overloading. Java supports method overloading, allowing a class to have multiple methods with same name but different parameter lists. The appropriate method is chosen at the compile time based on the arguments provided during the method invocation. Constructor overloading. Similar to methods, constructors in Java can be overloaded. This allows a class to have multiple constructors with different parameter lists, providing flexibility in object initialization. Object equality. The equals method is used to compare the equality of objects. It is often overridden in classes to define custom equality criteria. The equal to operator compares objects' references, not their content. ToString method. The ToString method is commonly overridden to provide a meaningful string representation of an object. This is useful for debugging and logging. Static members. In addition to instance variables and methods, Java classes can have static members. Static members are associated with the class rather than the instance of the class. Object cloning. Java supports object cloning using the clone method. However, for proper cloning, the class must implement the clonable interface and override the clone method. Serializable interface. Objects can be serialized in Java to convert them into a byte stream, which can be stored or transmitted. The serializable interface is used to indicate that a class can be serialized. Object lifecycle. The lifecycle of an object involves its creation, usage, and eventually garbage collection when it is no longer reachable. Developers can influence the object lifecycle through appropriate memory management practices. These are the advanced aspects of Java object. Let's look at these aspects in detail. Object composition. Objects can be composed of other objects. This is known as object composition, where one class includes an object of another class as a field. This allows for building complex structures and promotes a modular design. Interfaces. Java supports interfaces, allowing a class to implement multiple interfaces. This facilitates achieving multiple inheritance of behavior, even though Java supports only single class inheritance. Anonymous objects. Objects that are instantiated without assigning a reference variable are known as anonymous objects. They are used for one-time operations and are not stored for future references. Wrapper classes. Java provides wrapper classes for primitive data types like integer for int, double for double, etc. These classes enabled treating primitive data types as objects, and they offer additional utility methods. Immutable objects. Some classes in Java are designed to be immutable, meaning their state cannot be changed after creation. String is a classic example of an immutable class in Java. Object comparison. Besides using the equals method, Java provides the compare_to method in classes that can implement the comparable interface. This is commonly used for sorting objects in collections. Object locking. Java supports synchronization through the use of locks. Objects can be used as intrinsic locks and the methods can be marked as synchronized to control access in multi-threaded environment. Object serialization and deserialization. Java provides a mechanism to serialize objects into a stream of bytes and later reconstruct them. This is particularly useful for persistence and network communication. That's it for the video, guys. If you enjoy the content, like the video and subscribe to my YouTube channel. See you on the next video. Bye bye.